Hi girls, so I'm just going to talk you through the last two questions on the assignment, which were really tricky questions, and I can see that you struggled with. So make sure that you're making full notes, please. Pause the video as you need to. These are just printouts of the same questions, and email me if you still don't understand anything. Okay, so your first question is a solving simultaneous equations question. So your first equation, y equals 3x plus 5, is the linear equation. And we know that because the highest power of x is 1. And the second equation is a quadratic equation. And we know that because the highest power of x is 2. And whenever you do these types of questions, you have to substitute the linear equation into the quadratic. That's the most important thing to remember. Substitute the linear equation into the quadratic. So I'm going to write out my quadratic equation because that's what I'm going to substitute into. And I'm going to take my linear, okay? Now my linear is already in a really nice format because it's y equals already. So I can swap that y for the y in my quadratic. So I'm going to replace that with 3x plus 5. So I get 3x plus 5 equals 4x squared plus x. So see, all I've done is I've substituted in their y to the quadratic y. Now, all I need to do is just rearrange it and solve it as a normal quadratic. So this side has already got my positive x squared. It's much easier to solve if we've got positive x squared. So I'm going to move everything over here. So I'm going to have 4x squared plus x, and then I'm going to move that 3x over. So the sign is going to change to a minus 3x, and I'm going to move my plus 5 over, which means the sign is going to change to a minus 5. So now that all equals 0. Collect the like terms. So 4x squared minus 2x minus 5, and then just solve it. So I'm just going to see if I can solve this by factorising first, which would be nicer. So a times c gives me minus 20. What two numbers times to make minus 20? If I just do 20 first. So 10 and 2, 5 and 4. That's not going to work. That's fine. So I know I can't factorise it. So let's try and solve it by using our quadratic formula. So I've got x equals minus b squared minus b plus or minus b squared minus 4ac over 2a. So a equals 4, b equals minus 2, and c equals minus 5. So I'm going to substitute those in. So I get x equals minus 2 plus or minus 2 squared minus 4 times minus 5. So I'm just substituting 2 times 4. That gives me plus 2 plus or minus 2 squared, which is 4, and then minus 4 times minus 5 is plus 80 over 8. So now I've got two answers to my solutions. I've got 2 plus 84 over 8, or 2 minus root 84 over 8. I want it to correct two decimal places, so I'm going to use my calculator and type that in. So use the fraction button on your calculator, it would be much easier. 2 plus root 84 over 8 gives me two decimal places 1.40. And then change the sign to a minus. Nope. And we get minus 0.90 to 2 dp. Okay, so that's your first one done. Okay. Right, second question. So this one was really hard. So this is saying prove algebraically that the straight line with the equation x equals 2y plus 5 is a tangent to the circle with the equation x squared plus y squared plus 5. So your hint here is again that you've got a linear equation and you've got a quadratic equation. And I'm just going to think about this in terms of what this means in circles. So we've got a circle, doesn't matter what it looks like, where it is on the graph, it's just a rough sketch. And we're proving that this line is a tangent to the circle. So if it's a tangent to the circle, that would mean that it touches the circle at exactly one point only. So a tangent touches the circle at exactly 1 point. So that's what we're trying to find. So that means if I solve those two as simultaneous equations, I should get only one solution, and that will prove not only that they meet at that point, but also there is only 1 point that they meet at, so therefore it must be a tangent. So, same as before, I'm going to write out my quadratic to start, and then I'm going to take my linear equation and I'm going to substitute that in. So it's in the form of x equals, which means it's nice and easy to substitute in the right hand side of it into where the x is in the equation. So I'm going to replace that x with my linear. So I get 2y plus 5 squared plus y squared equals 5. And I just need to tidy that up and solve it now. So I've got some brackets to expand on the left hand side. So I'll write it all out for you. 2y bracket 2y plus 5 bracket 2y plus 5 plus y squared equals 5. Expand the brackets and we get 4y squared plus 10y plus 10y plus 25 plus y squared equals 5. Collect the like terms. 5y squared plus 20y plus 25 equals 5. And then move it over so it all equals to 0, because that's what we need to solve anything. So 5y squared plus 20y plus 20 equals 0. Now, I can see that there's a common factor of 5 that's going throughout, and because it's an equation, because it's balanced, I can divide everything by 5. So I'm going to get y squared plus 4y plus 4 equals 0. Okay? And then I'm going to think, can I factorise it? So yeah, I can factorise that. Y plus 2 equals 0, which means my solution is at where those brackets equal to 0, which is y equals minus 2 and y equals minus 2. And because they're the same, that means there's only one solution. Okay? So there's only one y solution. So just to fully complete that, I'm going to now take that y value and I'm going to substitute it back in to my linear equation, because that's easier, to find out what the x coordinate would be. So I've got x equals 2y plus 5, x equals 2 times minus 2 plus 5, x equals minus 4 plus 5, x equals 1. So the coordinate of intersection is at 1 minus 2, and there is only one coordinate, which means there's only one solution. So we'd have to conclude this with a statement. So there is only one point of intersection which means the line must be a tangent. Okay, let me know if you've got any questions, girls. I know I've gone a bit quickly, but just keep pausing it, watch it again if you need to, and email me with any questions. Okay, bye, take care.